Google's latest AI ambition is to create a system capable of simulating the entire physical world. Yes, it's real, and it's happening right now at Google DeepMind. In this discussion, we'll explore what this means, why Google sees it as a critical step toward achieving artificial general intelligence, AGI, and how it fits into their broader AI strategy, including the rumored Gemini 2.0 update. We'll also cover some major announcements about Google making AI more accessible in Workspace and how this ties into the broader AI race, particularly against Microsoft. Let's dive in. First off, Tim Brooks, who was previously with OpenAI, left the company last fall and joined Google DeepMind. He's now leading this new initiative focused on world simulation. What does world simulation mean? It's about building an AI model that can understand and replicate the physical laws governing our planet. This involves training the system on massive streams of multimodal data, video, audio, robotic sensors, and more, enabling it to predict events in a given environment. Essentially, it's like teaching AI to think the way humans rely on physics to navigate daily life. The ultimate goal? These systems could become so advanced that they pave the way to AGI. Brooks has emphasized the sheer scale of this project and how it's deeply interconnected with other Google AI ventures like Gemini, VEO, and Genie. Gemini, as you may know, is Google's next-generation large language model, while VEO is focused on video generation, and Genie is a foundation model that can create entire 3D playable worlds from just a single image. When you combine these technologies, large language models, cutting-edge video generation, and the ability to craft 3D environments, you begin to see how they're building toward an AI capable of understanding real-world physics. This aligns with Google's strong belief in the scaling hypothesis, which suggests that by continually increasing data and parameters, AI models will keep improving significantly. However, not everyone agrees. Critics argue that we might be reaching the limits of what scaling alone can achieve. Data is finite, and the environmental impact of training massive models is concerning. Many experts believe the focus should shift toward developing new architectures instead of just making models larger. Despite this, Google is pressing forward. Job postings for this world simulation team indicate they consider scaling to multimodal data, including video, as vital for achieving AGI. They're actively recruiting for positions like Research Engineer World Modeling at their Mountain View headquarters, emphasizing the goal of pushing world simulators to the limits of current computing power. So why bother simulating the entire real world? There are plenty of reasons, ranging from advancing AI's ability to solve real-world problems to creating next-gen technologies that could revolutionize industries. Google's commitment to this ambitious project demonstrates their belief that this could be the key to unlocking the next frontier of artificial intelligence. If we can accurately simulate real-world physics, the possibilities are groundbreaking. For instance, robots could be trained in virtual environments, which are infinitely safer and more cost-effective than trial and error in the real world. Imagine a robot learning to walk, not by physically stumbling around, but by practicing in a simulated environment until it's ready to navigate real floors effortlessly. Beyond robotics, this technology could revolutionize video games and interactive entertainment. Developers could use these advanced physics simulations to create game worlds that feel incredibly realistic. Picture a game where every object and environment behaves with near-perfect realism, powered by an AI that understands the laws of physics. But the potential applications don't stop there. Researchers could leverage these simulators for scientific experiments, such as modeling weather patterns or simulating the spread of viruses within a population, all without requiring real-world testing. These systems could also enhance real-time interactive scenarios, enabling AI to understand context, environments, and even human body language, making it feel like something straight out of a sci-fi movie. Speaking of futuristic developments, there are rumors about a major update to Google's Gemini model. Dubbed Gemini 2.0 Flash Thinking Expanse 123, it's reportedly set to launch on January 23, 2025. This information allegedly surfaced during a Google Hackathon livestream, where a participant named Pan Weifeng revealed some details. The name flash thinking suggests faster or more dynamic reasoning, which could improve decision-making in real-time simulations. If true, this ties directly into Google's New World Modeling initiative. There's speculation that these flash thinking capabilities might be integrated into Google's AI Studio platform, giving developers powerful tools to build advanced simulations or immersive experiences. Now, let's return to Google's job posting for research engineer, world modeling. A closer look reveals their focus on building infrastructure for generative models of the physical world. The role involves tackling some of the toughest challenges at scale, training these simulators on massive datasets, creating metrics for what they call physical intelligence, and working on real-time interactive generation while integrating it all with multimodal language models. This is no small feat. It's not just about analyzing text or images, it's about creating dynamic 4D simulations that combine time and space. The job ad also references the bitter lesson, a well-known concept in AI that emphasizes how simpler, scalable methods often outperform complex, hand-engineered solutions. In line with this, Google might focus on keeping the architecture straightforward to ensure scalability without introducing unnecessary complexity. This approach underscores their belief in scaling as a pathway to AGI and demonstrates how world simulation could become a foundational element in AI's future. Here's another critical piece of the puzzle. Google is shaking up its enterprise strategy by making AI features free for all Workspace subscribers. Previously, businesses had to pay an additional $20 per user per month to access Gemini Business. Now, Google has folded that cost into the standard Workspace subscription, which has increased slightly from $12 to $14 per user. For just $2 extra, businesses gain access to a range of AI-powered features, such as auto-generated spreadsheet designs, meeting summaries, an AI-driven note-taker, video editing tools, and more, without the previous paywall. On the other hand, Microsoft is also in the race, recently launching a free version of its Copilot chat for Microsoft 365 users, alongside a pay-as-you-go option for agents. Microsoft still offers its premium $30 per user per month plan for those who need full access to advanced features. But the fact that both Google and Microsoft have made these announcements within the same week shows just how intense the current AI arms race has become. Both companies are competing to onboard as many users as possible into their respective AI ecosystems. The strategy is simple: get more people using your AI tools to build brand loyalty, gather more user data to improve models, and maintain an edge in delivering cutting-edge AI solutions. Google's president of cloud applications, Jerry Dishler, explained that one of the main hurdles for businesses adopting AI has been cost. By eliminating the extra fees and slightly raising the base subscription price, Google is signaling that they want businesses to experience the benefits of AI without significant financial barriers. For Google, bundling these AI tools into the existing Workspace subscription might encourage more users to explore their capabilities, reducing friction and allowing people to see the immediate value of AI. Of course, this could come with trade-offs, such as increased resource demands or users who don't need AI feeling like they're subsidizing those who do. But from a broader perspective, it's a bold move to drive rapid AI adoption. How does making AI more accessible lead to something as ambitious as a world model? It's straightforward. More users mean more data and feedback loops, which help AI gain deeper insights into how people work, whether that's drafting emails, analyzing data, or collaborating in teams. Combine this user-generated data with Google's vast video libraries, advanced 3D modeling tools like Genie, and real-time robotics inputs, and you have a system capable of simulating real-world behaviors in virtual environments. However, building a true world model isn't without its challenges. Physical laws are highly complex, the amount of data required is enormous, and ethical concerns must be addressed. This is why Tim Brooks at Google DeepMind has emphasized the importance of cross-disciplinary collaboration to tackle these issues. Meanwhile, rumors surrounding Google's Gemini 2.0 Flash Thinking Expanse Explorer 1.2.3 suggest a significant leap forward, especially as the competition with Microsoft intensifies in 2025. So, are we genuinely moving toward AIs that can fully comprehend and simulate the physical world, or is this all just overhyped marketing? Let me know your thoughts in the comments. And if you enjoyed deep dives into cutting-edge AI developments, don't forget to like, subscribe, and stay tuned for more updates.